Guys, in this video, we're going to solve some problems from the Math 145 Test 3 review packet. This is Michael Elmes, and we're going to start with question number 57. So for these problems, listen, you could graph both sides of the equal sign, or you can solve them as proportions, right? So if I have 2 over 3, and I set that equal to the 1 over 2x plus 1, you can cross multiply, right? You could do 3 times 1 and set that equal to 2 times the quantity of 2x plus 1. So it looks like this, 2 times 2x plus 1, set that equal to 1 times 3. So when we clean this up, we get 4x plus 2. And that's going to be equal to 3, right? 1 times 3 is 3. We can subtract 2 from both sides, and we're left with 4x equals 1, or x equals 1 over 4. All right, and that's our final answer for number 57. All right, so I'll leave this up for a moment, and then I'm going to erase and handle question number 58. So if you want to pause the video for a minute and write the notes down, that's fine. I'm going to erase this momentarily. All right, so for number 58, again, we're going to cross multiply, right? So I have 1 over z minus 1, and I set that equal to 2 over z plus 1. And when we cross multiply, you get 2 times z minus 1, and that's equal to 1 times z plus 1, okay? So 2 times z minus 1 is 2z minus 2 equals z plus 1, okay? So if I subtract z from both sides, on the left side I'm left with z minus 2 equals 1, and then I add 2 to both sides to get z equals 3, okay? Sorry that my z's and my 2's look the same. Let's do one more of these, okay? When I look at number 59, right, you can't solve a proportion unless you have basically one expression on each side of the equal sign. So let's rewrite this problem, right? Since my denominator is the same, I can simply subtract across my denominator. So 12 minus 2 is 10 over y plus 1, right? And set that equal to 5, and I'll put it as 5 over 1, right? Because 5 and 5 over 1 are the same. And then we cross multiply, right? The 5 times the quantity of y minus 1 and 10 times 1. So you get something that looks like this. And set that equal to 10, right? 1 times 10 is 10. So you end up with 5y plus 5 equals 10. We subtract 5 from both sides to get 5y equals 5, or y equals 1, right? You divide both sides by 5, you get, let's just write that a little neater, y equals 1. It's my final answer for number 59, okay? Let's jump into problem 61, 62, okay? Now we're dealing with radical functions, okay? So let's read the problem, and then we'll tackle 61. All right, so 61, it looks like they give us some type of function, I'll underline it here, that will give you the speed of the car if you know the length of the skid mark in feet, right? So x is the length of the skid mark, and s is the speed of the car. And I assume the greater the skid mark, the greater the speed, but the same could be said for the opposite, right? The faster the speed, the greater the skid mark. So 61 says, use the function to determine the speed if the skid mark in the accident scene is 115. So x equals 115. So really, we're solving this. S equals the square root of 24 times 115. I'm going to put that into my calculator. This is a 4. All right, so S equals, we'll pull out our calculator and see what we get. So I've entered it, right? 24 times 115, I press enter. I get approximately, we'll call it 52.5 feet. So S equals 52.5. And you might see some books actually use the wavy equal sign to say approximately 52.5 feet. All right. Oops, not feet. It was the speed of the car. I'm sorry. So we should call this, instead of feet, we should say it's 52.5 miles per hour. Right? That's how we measure the speed of a car. All right, let's take a look at number 62. 62, they give us the speed, all right, but we don't know the skid mark length, okay? So let's tackle that. So we know S is now going to be 80, but we don't know the X. Right, so we have to solve this thing for X. So we got a couple of options. We could square both sides of the equation, right? So I could do something like 80 squared equals 24x, right? Because when we square a square root, it has the effect of basically removing the square root or the radical sign. So then to finish the problem, we would divide both sides by 24. So we have 80 squared over 24 equals x. So let's put that into our calculator. So it looks like we have something like this, right? 80 squared divided by 24. I press enter. I get 266.7 feet, right? 266.7. And remember, that's in feet. All right, so if you see skid marks at 266.7 feet, that means the car was traveling at about 80 miles per hour. Okay. Let's do a couple more. 63 to 65. So we can put all of this under the radical sign, right? 3 times 2x, which then becomes the square root of 6x as your final answer. Let's write that neater. That's my final answer, right? And if I do number 64, again, I can put all of this under the radical sign, 5y times 7x, right, to get 35xy. As my final answer. So let's take a look at number 65. We have we can write all of this under the radical sign, right? So 3a times 3b. That would give me the square root of 9ab. And we know that the square root of 9 is 3, and we're still left with the square root of ab. So 3 times the square root of ab is the answer for number 65. Okay? Let's take a look at number 60, or 66. I want to erase some of this. So let's take a look at number 66 and 67. All right, 66, we can rewrite the square root of 20 as the square root of 4 times the square root of 5, right? Because 4 times 5 is 20. And the square root of 4 is 2, and we still have that square root of 5. So this is your final answer for 66, right? 67 we can rewrite as the square root of 25 times the square root of 2, right? 2 times 5 is 50. And we know the square root of 25 is 5, and we're left with times the square root of 2. All right? That's number 67. Number 68. All right, so we have the square root of 72 times x squared. So I'm going to break this down. How do we get 72? There's a couple of ways. You could do 36 times 2. That's the best way to do it, right? The square root of 36 times the square root of 2. right? 36 times 2 is 72. And then we can rewrite this as times the square root of x squared. So 36, the square root of 36 is 6. The square root of x squared is x. And we still have square root of 2. That's my final answer for 68. Okay. 69. All right, same thing. We're going to break it up as much as we can. Oops. All right, so 69 is going to look something like the square root of 25 times the square root of x squared times the square root of x times the square root of y squared. Now I broke up x cubed into x squared and x, so I can take the square root of x squared. Right, the square root of 25 is 5. The square root of x squared is x. There's nothing we can do with the square root of x, but the square root of y squared is y. So if I put this all together, I get 5xy times the square root of x as my final answer for number 69. Okay, one more to go, number 70. All right, so let's try to think of a big number we can use to break up 300. I'm thinking 3 times 100, so square root of 100 times the square root of 3 times the square root of x squared times the square root of x. That's how I get my x cubed. And then for y to the 7th, I'm going to write the square root of y y to the 6th times the square root of just single y. That gets me y to the 7. So the square root of 100 is 10. The square root of 3 is just the square root of 3. Can't do anything with that. Square root of x squared is x. Square root of x is square root of x. Square root of y to the 6 is y cubed. And the square root of y, we can't do anything with it. So let's put everything together. The 10 goes here. Then we have an x times a y cubed. That's this piece and this piece. What else do we have? We have a square root of 3. Right, square root of 3, square root of x, and a square root of y. And I think that's our final answer. Okay, so I'm going to stop the video here. In the next video, I'll tackle problems 71 to 73. Thank you for watching.